Hello, physics. I wanted to kind of address some of the confusion you guys have been having recently, so I'm going to go ahead and show you a little bit of what I expect from you guys on this project here. This is our summative assessment for our unit on simple harmonic motion, and in short, you're going to be designing an experiment for a pendulum. So as you know, yesterday's assignment was to take some household materials and to build a pendulum, and also to make a calculation of the length of that pendulum. So if you look in this folder right here, I know there's a lot of information. The information right here is generally just sort of following up with Friday's assignment, and all of the information in this first section here, Friday's assignment posed a question to you, is really just related to minimizing the length of the minimizing the error of the pendulum. Because you guys are going to be changing the length of a pendulum, and you're going to be measuring the time it takes for the pendulum to oscillate. And when we make measurements of time, there's always error associated with that. For example, human reaction time is about a quarter of a second, 0.25 seconds. So there's an error that we want to try to minimize, and that's kind of where this first part here is talking about. If you did yesterday's assignment, then the last thing you did perhaps after building your pendulum was what you made a quick calculation. So we'll talk about that in just a moment. So this part of the assignment right here just encouraged you to build your pendulum and to do so safely, and it gave you a few tips on how to do this to make a pendulum that's going to be good for the experiment. I'm not going to read it to you. I assume you guys can do that on your own. With that said, if you did this last part, if you look at the bottom here, it says to be 100% clear, for today, all you need to submit is the minimum length of the pendulum such that the period is 2.5 seconds. That requires this formula here, which is t equals 2 pi times the square root of L over G. So if you plug in for t, 2.5 seconds right here, so this t right there, you would plug in 2.5. If you do that, then you can solve for L, okay? So the first thing to do to solve for L would be to divide both sides by 2 pi, right? And then after doing that, you would square both sides of the equation. And then lastly, you would multiply by G. So if you do that and you do it correctly, then you'll get the minimum length for the pendulum that we were talking about. And this is so that the error is minimized. And if you do this, you get about that's 2.5 seconds for the time. You actually get about 1.56 meters for the length of your pendulum. Now, 1.56 meters is actually pretty big. It's about 5'2", so it's not a trivial distance. And so your pendulum is actually going to be pretty big. With that in mind, actually, I want to erase that real quick. I don't want that to be, I don't need to rate your app, guys. Anyway. So we're going to go ahead and erase that because I don't want to permanently do that. But in any case, the whole idea here is that you would get about 1.6 meters for the length of your pendulum. So as you built your pendulum, hopefully that's kind of where you were going with that. So with that in mind, we're going to go ahead and talk a little bit about today's assignment. So let's go ahead and take a look at that. And keep in mind that for today's assignment, you actually have a couple days to do this. This isn't due until tomorrow night. So, don't put it off, but you don't have to rush through it. And I want you guys to do a good job. But I want to make sure you understand what's expected of you. Okay? So, what you're going to be doing for today's assignment is making sure that you understand the goal of the experiment that you're going to be conducting. And then you're going to be writing experimental procedures. Now, if we look at the example lab procedures that I posted here, these are the kinds of procedures that I'm talking about right here. This is what you have to write. It's basically a set of instructions for you to follow as you conduct the experiment. So you're writing procedures for yourself to follow. So if you do a good job writing those procedures, then your experiment should actually be really easy to conduct. And if you kind of, take some shortcuts and you don't do a great job, then it's going to be a bit of a pain for you. So keep in mind that's what we're talking about, is writing experimental lab procedures. I have my equipment in front of me. How do I conduct the experiment? So as you see here, this isn't like, that trick exercise where you have to write, the instructions for a peanut butter and jelly sandwich and you have to not leave any tiny mundane step out. Instead, I want you guys to just assume that whoever's reading your instructions, you, will have some understanding of what's going on. So just reasonably detailed instructions that lay out clearly what you're doing in your experiment. To be clear, the goal of your experiment is simple: to investigate the relationship between the length of the pendulum and the amount of time it takes for the pendulum to oscillate back and forth. You can, after you investigate that, we're also going to make a calculation of the acceleration due to gravity, which is g at your location. So setting up your pendulum to minimize error is important because ultimately you're going to be calculating g. And if you don't do a good job minimizing your error, meaning making your pendulum long enough and doing a good job with your experimental procedures, then when you calculate g, you're going to get a value that is really far off from what we know to be true, which is approximately 9.8. So you should expect, of course, that gravity near your location is around 9.8, but it might be a little less or a little more. As it says here, you're going to begin by identifying your controls. So what isn't changing with your pendulum, right? Well, we know the length of the pendulum is changing, but what else what else could you change that you're not, right? So just think about some of the factors that are staying the same throughout. List your independent and your dependent variables. So the dependent variable would be the time, because you're going to see how the time depends upon the independent variable, which would be your length. Okay, so I just helped you out a little bit there. With that in mind, when it comes to best minimizing error, the first thing that we did with this was that we chose to determine the length of a pendulum that's actually pretty big, because we wanted the time for its oscillation to be substantially large. So if we had chosen a very small pendulum, then the time would be very small, and this would lead to large errors in your measurement for time, so we're not doing that. So the first thing we did to minimize error was we went ahead and we minimized, we made a large pendulum. Now, in order to minimize error further, I'm not going to tell you just yet. I'm going to instead encourage you to think carefully about it. How could you make measurements of the time of the pendulum in such a way so that the time that the error associated with that time has minimal impact? So again, your reaction time to pressing the button when you make a measurement for the pendulum could be as much as a quarter of a second. And we want to make sure that that quarter of a second is small compared to the time measured. So how can you make sure that you're minimizing the impact of error? Once you've considered those factors, you should be able to write a rough draft. This rough draft should be, again, experimental procedures. Step 1, I'm going to make sure that my pendulum is secure, and I'm going to measure the length of the pendulum. Step 2, I'm going to pull it back and release it. Step 3, etc. So I kind of got you guys started there, but I want you to make sure that you're writing these procedures in such a way that somebody who is in a physics class could follow them, and because you're going to be following them in the coming days, and I want to make sure you do a good job. All right. Then, of course, you need to include data tables. So when it comes to what information needs to be included in the data table, just think of the purpose of the experiment. What are you varying? What are you measuring, right? Well, I'll just help you out here. You're varying, as I said, the length of your pendulum, because that is what we're investigating. How does the length of your pendulum affect the time? And of course, you're measuring the time or the period. So at the very least, you need to include things like length and time in your data tables. As it says here, if you want to work ahead a bit, you can start thinking about your data analysis. This would be difficult to do, but if any of you over the next day or two find yourself into the experiment and you're wondering, oh, well, I wonder how this is going to go, you could start thinking about how it is that when you make these measurements, you're going to use those measurements to figure out, for example, the acceleration due to gravity, or investigating that relationship between the length and the time. How can you analyze your data to understand the relationship between length and time? So your submission is due before midnight tomorrow night, 4/22 Wednesday. Make sure your procedures are legible and numbered. As always, you can ask questions via email or Google Hangouts. If you want to do Google Hangouts, when I say that, what I mean is, of course, two options. Number one, chat. My students have been chatting me up via Google Hangouts when they have questions. It's like instant messaging, and it's very, very quick, and I get notifications and can immediately respond. But if you feel like you have to ask questions in person or face-to-face, we can do a face-to-face sort of Google Hangouts or Zoom session. So please let me know what you guys feel like you need. I'm hopeful that this video is helpful for you when it comes to understanding what you're supposed to be doing. And I wish you luck. Please make sure that you take your time and you do a good job on these procedures, because these are an important part of your summative assessment. Take care, guys.